Hello everyone, welcome to the channel SRS. This is Sumit Roy and we'll study JK flip-flop today. In the last class we have discussed about SR flip-flop and there was a drawback in it. That is, the drawback was that is during S and R both 1-1, the output remains indeterminate. That is, it cannot be decided. So in JK flip-flop that problem has been rectified, and to an extent it is rectified because that will lead to another problem. We'll discuss it later. That is, during 1-1 at the input J and K, the output what we'll have is it will be toggled. It will be 0 to 1 and 1 to 0. So let us begin with the JK flip-flop. Work order obviously will deal with J and K here. JK flip-flop. So work order will give us JK and the output. So if it is 0 and 0, 0 and 1, 1 and 0 and 1 and 1. So for 0 and 0, output will remain no change. For 0 and 1, it will remain reset, that is 0. 1 and 0, it will remain set, that is logic 1. And for 1 and 1, it will be converted, that is Q bar, that is known as toggle. It will be inverted. Whatever is the present output, the next output will be inverted. If it is 0, it will be 1. If it is 1, it will be 0. So that is the new thing. That's a new thing that is added. In SR flip-flop, we were facing that it remains indeterminate. In this, it is toggled. Based on this characteristic table, now in characteristic table, that is QT will be there, J and K will be there, and QT plus 1 will be there. So this is the part. Now this is 0. Possible inputs are 0, 0, 0, 1, 1, 0, 1, 1. Again, if the present output is 1, possible inputs are 0, 0, 0, 1, 1, 0, 1, 1. Now, if 0, 0 is there, 0, 0 means no change. No change means Q only, no change. Whatever is the output, present output, next output will be remain the same. 0, no change, 0. 0 for 0, 1, it is already reset, so it will be remaining 0. For 1, 0, it will be 1. And for 1, 1, now it is 0 here. So for 1, 1, it will be inverted, flipped, toggled. That is, for 0, it will be 0 bar, that is 1, that is toggle condition. This is no change condition. Again, 1, 0, 0, no change, carry forward. 0, 1, it is 0, 1, 0, it is 1, and 1, 1, that is 1. So 1, 1, it will be toggled, it will be toggled to 1 bar, that is 0. This is toggle, this is no change. So this is characteristic table. Now I'll write the zeros and ones. So this is characteristic table. Based on this excitation table, third excitation table, excitation chart, whatever you want to call it, excitation chart table. So QT plus 1, J and K. What is the possible transition? 0 to 0, 0 to 1, 1 to 0, 1 to 1. For 0 to 0, if the transition is occurring from 0 to 0, now we'll take the help of this. That is 0 to 0. In this case, first and second case, both 0 to 0, 0 to 0 is transition is occurring. Possible input is J is 0, obviously J has to be 0. K, we should not care about it because in 0, if this transition is occurring, in 1 also this transition is occurring. So, don't care about it. Then there is 0 to 1. So, 0 to 1 and 0 to 1. Again, these two cases are there, 0 to 1 and 0 to 1. So, J is 1, so J is 1 and K is 0, 1, that is indeterminate. Now, in the third case, that is 1 to 0. So, this is the case 1 to 0. This is the case 1 to 0. These are the two cases. 1 to 0 and 1 to 0. 1 to 0 and 1 to 0. So 1 to 0 and 1 to 0, so K is 1, K is definitely 1. and J we should not care about it. In this case it is 0, in this case it is 1. So in both these cases, look here, in both these cases, if it is not consistent, J is not consistent, so indeterminate. And lastly 1 and 1. So this is 1 to 1, 1 to 1. This double ticks are 1 to 1, 1 to 1 conversion. So 1 to 1, 1 to 1, that is, in this case JK is 0, 0, in this case JK is 1, 0. So 0 is definite and this remains indeterminate. So this is excitation table. And last is characteristic equation. So characteristic equation is again derived from characteristic table. So only by the help of K map, QT and J and K. This is 0 and 1, this is 0, 0, 0, 1, 1, 1, 1, 0. So for 0, 0, now you can read it like this only, that is 0, 0, 0, it is 0, 0, 0, 1, it is 0. So I'll just give the input 0, 0 and 1 and 1, 1 and 1. Then 1, 0, 1, 0, 1, 0, 1, 0. Now this is the possible. So QT plus 1 is written as, this is it. So it is Q bar, QT bar and 1, that is J, plus 0, 0 and that is QT, and 0, 0 and 1, 0, this 2, that is K bar. So this is what we are looking for. I'll write it in a proper manner. That is QT plus 1 is QT bar J plus QT K bar. This is characteristic equation. So these 4 parts consist of all the knowledge that is required for flip-flop. So this is JK flip-flop. The only difference from SR flip-flop to JK flip-flop, that is, we'll see also it in the conversion part, that is, during SR flip-flop, 1 1 gives indeterminate state, and during JK flip-flop it gives a toggle condition. So that is the advancement. But this toggle condition also will cause a certain sort of problem, and that is known as race around, and we'll discuss it in the later episodes. So till then, goodbye. Actually, we'll study the next flip-flop will be D and T, and then we'll enter the conversion part. So till then, goodbye. Comment, share, like, comment, share, and do comment if there is any doubt. I'll try to solve all of them. Thank you.